Good morning. So we are going to start combing through our September math standards. And I figured out last year that a lot of our standards, we need to do a little review before we move forward with them. So as part of our review for this first piece, we're going to talk about a little bit of what you did hopefully in 6th grade to prepare you better for what's coming up. So first things first, we want to look at our I can statement. So I can compute unit rates with ratios of fractions. So hopefully you know what fractions are, and you should have learned ratios last year, but let's review real quick. So a ratio is just a comparison of two quantities, and ratios can be written 4 different ways. You can see we have A over B, we have A slash B, we have A with a colon B, and we have the word spelled out A to B. Either of those is correct. The only challenge with ratios is making sure you get the right number in the correct location. So let's do a little practice. On this screen, it says work with a partner. I'll be your partner, you'll be my partner. When we work with ratios, our goal is mainly just to organize the information we see in front of us. If we're looking at this picture, we may not readily be able to count what we need and go, so we're going to quantify this information. So we have some graphing calculators, some protractors, and some compasses. When we work through ratios, we're truly just counting what we have in front of us. So there are blank graphing calculators to blank protractors. Well, if we look at that picture, I can count 1, 2, 3, 4, 5 graphing calculators. So I can go ahead and write my 5 right in that blank. And wherever I see graphing calculators, I can put 5 because I know that the number of graphing calculators in this specific example won't change. None will be erased, none will be added because it's on paper. So this 5 is going to be true for all of these prompts. Now I'm comparing graphing calculators to protractors on that first one. So how many protractors do I have? 1, 2, 3, 4, 5, 6, 7. So I'm going to put my 7 right there in the blank. And I can do that everywhere I see the word protractor because, again, that number will not change. The last piece of information, I have my compasses, and I can see by counting that there are 4 compasses. So just by counting my objects in this picture, I'm done with 4 problems. I have 5 graphing calculators to 7 protractors. 7 protractors to 5 graphing calculators. So that example, these first 2, is the example I mentioned earlier where order matters. If I'm calculating my ratio of graphing calculators to protractors, I want to make sure my number matches my picture. In these last 2, we are comparing a part to the whole, meaning we're looking at one part. So in this first example, we're only looking at those protractors, but we're comparing them to all our objects. So how many objects do we have total? We can either count them all up, we can use the numbers that we found in the other equations and add those up. However you want to do it will be fine here. So I should have 5 graphing calculators plus 7 protractors plus 4 compasses, and that should give me 16 total objects. If I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, I get the same number. So ideally, it doesn't matter which way you do these. You will get the correct answer. So hopefully that's a quick review of ratios for you. We'll continue to practice those when we're together. I have some cute little ideas to help us with that, but this should hopefully give you a nice overview. So now that we know what ratios are, we can move on to talking about rates and unit rates and unit cost. So a rate is just a comparison of two quantities, much like a ratio, but the two quantities have different units. So we'll do some practice so you get an idea of what that means. But a unit rate is a rate when our denominator is 1. So we could be talking like miles per gallon, we could talk miles per hour. There's so many different rates we can talk about, and unit rates. When we're talking in terms of money, we're going to add 1 to this, because when we bring money into it, if we're talking about the cost of just one item, it is a unit cost. So we'll do some examples where you'll be able to distinguish unit rates from unit cost. So here's some examples of rates. We have 2 pictures here, and we want to kind of make sense of them. So rates allow us to make sense of what we see. So we have pictures, and if you're quick glancing at this, it might be hard to understand what's happening. So we're going to dig deeper into this. So looking at prompt A, we see we have a car that has traveled 80 miles. And we have some clocks. This clock here is reading 11:15, and this clock over here is reading 1:15. So how much time has passed? We could go 12:15, 1:15, 2 hours. So this little red car in 2 hours time has traveled 80 miles. When we're talking a unit rate, we want to know how far did this car travel in 1 hour. So we're going to set up a proportion. Proportions are just equivalent ratios or equivalent fractions. So how far did this car travel? This is our unknown, and in math we use variables to talk about those unknowns. So there are several different ways you can figure this out. If the numbers are simple enough, you might just be able to mental math it and figure it out. I want to expose you to the different ways you can do to solve this problem, but I don't want to confuse you. So, method 1, we can cross multiply. We're going to take our 2 and multiply it by x, which will give us 2x. Then we'll take our 80 and multiply it by 1, and that gives us 80. So 2 times some number equals 80. In order to figure that out, let's divide by 2. So x equals 40. So in 1 mile, this car drove 40 miles. That's our unit rate. That is our miles per hour. He is driving 40 miles per hour. So hopefully he's not on the expressway, because that's extremely slow. So 1 hour is 40 miles. If he drives another hour, that's 40 more miles, for a total of 80 miles. That makes sense. Good job. In our second example, we have someone cutting the grass. He starts at 12 o'clock, and he finishes at 3, because that would wake up the neighbors. And it's kind of hard to see, but he has $15 in his hand. So he earned $15 for how much work? Well, how many hours elapsed between 12 and 3? 3 hours. So $15 for 3 hours. Unit rate, we're asking how much did he get paid for just 1 hour? We can do the same steps we did over there. We cross multiply. So 3x equals 15. So 3 times what number equals 15? Let's do some division. And we find out that he earned $5 for every hour of grass he cut, which isn't too bad for cutting grass. So, bravo. We're going to pause here for now. When we come back, we're going to talk about some more complex unit rates. Alright, I'm going to walk you through 2 complex unit rate problems. And these are complex because they involve fractions. So in order to determine that, you need to ask yourself, what does this problem want me to figure out within what time? So like in this example, we're working with per hour. So this problem is asking me how many pounds per 1 hour. So I need to get this bottom of 3/4 to be 1. So my 5.5 I can leave up here. Now there's a couple different ways I want to show you how to work with a problem like this. So the first way is the traditional method, I think, when we're dividing fractions. And if you are a little bit confused on how to divide fractions, allow me to show you. So first things first, this is a really complex problem because we are working with a mixed fraction. This 5.5 is mixed because we have a whole number and a fractional piece. What we want to do first is convert this from a mixed fraction to an improper fraction. So how do we do that? Well, when we're working with 5.5, we're going to multiply our 2 times 5, and then we're going to add that number to 1. So 2 times 5 is 10, plus 1 is 11. That is our new numerator. Our denominator will stay the same. So 5.5 is the same thing as 11.5. Now when we are dividing fractions, we're going to keep that first fraction the same. We're going to change our division sign into a multiplication sign, and I'm going to use this dot because you will see that more and more this year instead of the X for a multiplication sign. And then our second fraction, we're going to write upside down, or our reciprocal. So 11 over 2 times 11 over 3, 11 halves times 4/3. Remember, when we're multiplying fractions, we're multiplying our denominators together, and then separately our numerators. So 11 times 4 is 44, and 2 times 3 is 6. We need to simplify fractions. There is no way around it. If you are struggling, we need to practice. Okay, so in order to simplify fractions, you're usually doing some division. So what number can you divide into both 6 and 4? 2, because they are both even numbers. So 44 divided by 2 will give me 22, and 6 divided by 2 will give me 3. This number means I can pick 22/3 of a pound of apples in 1 hour. Now you can convert that back to a mixed fraction if you want, or you can leave it improper. Either or is good for me. Second method to solve this problem. If I have 5.5 over 3/4, and I know I need my denominator to equal 1, what can I multiply 3/4 by to get to 1? This is a hint that you will use a lot. When we're working with fractions and we want it to equal 1 through multiplication, multiply it by its reciprocal. And we're going to do the same up here. So our bottom will now equal 1, and if you're paying attention, you'll say, wait a minute, we just did the math for our top, so I should know that that equals this. Because if I work this out like I did up here, I would have to change this 5/2 to an improper fraction, and then I can multiply across, follow my path, and I get my answer. So this is a test of what are you most comfortable with. Okay, so we'll just practice. We'll see what you're comfortable with. Whichever way you like is the way I recommend you do it. Don't change it up. Don't try to learn both ways. Find your way. Find your groove and stay in it. And I will assess your work based on where I know you're comfortable.